In this video, we're going to look at writing an equation from a graph. So number one, they tell us to write a quadratic function to model the graph shown. So I'm going to label a couple points here. I've got the point 3, 3 there. To make my life easy, I'm going to use this point 4, 4. All right, so first thing I want to look at is how did I get from the origin to the vertex of my graph? Well, I went right 3 and I went up 3. So now that I'm going to need to move right 3 places and up 3 places. I'm going to have to represent those changes in the function that I create. So my function, I want to have in the form f of x is equal to a. Now, this is a parabola. So since it's a parabola, I know it's going to be x minus h squared plus k. Right, so I need to write a function in that form that represents this function here. So my right 3 affects my h value, and my up 3 is going to affect my k value. And then I'll need to determine what my a value would be in a minute. So I'm going to have f of x is going to be equal to a times x. Now, since I'm going right 3, remember it's the opposite of what we would think. So if it's going right, we're subtracting that number. So that minus 3. Keep the squared, right, that's not going to change. And then if we're going up 3 places, we're going to finish that with a plus 3. So those numbers are determined, those are color coordinated. All right, so what I do need to do though is I need to figure out if there is an a value. All right, I need to know what a is. And to do that, I'm going to rewrite this equation as y equals a times x minus 3 squared plus 3. And then what I'll do from there is I'm going to take this second point. You can use any point on the graph. It looks like you can also use 5, 7, or even 2, 4. I'm using 4, 4. Again, any of the points, like you could have used this one, you could have used this one, any of these would work. All right, but for this problem, I'm using 4, 4. I'm going to plug that 4, 4 in as my x and as my y. And what that's going to do is that's going to create an equation where I only have one unknown, my a value. All right, so I've plugged in for x, y, h, and k, and now I can solve this problem and I can determine what my a value is. So 4 equals 1 squared would just be 1, so this is 1a plus 3. I'm going to subtract 3 from each side, and 1 in this case, 1a is just a, so a is equal to 1. That's good. That does make my life a little bit easier. So my function I'm going to use will be f of x is equal to. If you want to put that a value in there, you can. Remember, multiplying by 1 isn't going to change anything. So that 1 really is not necessary, but we do need to check to make sure that we need to figure out what the a value is. All right, because remember that can affect stretches and compressions as well as reflections. So that would be it for number 1. We determined our function based off the graph that we were given. In number 2, we're doing the same thing, and now what I notice here is I definitely have some type of stretch or compression here. All right, my a value is not going to be 1 in this problem. So I want to do the same thing. I'm going to ask myself, how did I get from this vertex, or sorry, how did I get from the origin to the vertex? All right, well, it looks like I went left 2 places, and I went up 4. So I'm going to put this in the form f of x equals a times x minus h squared plus k. So my h values, my k values, all that fun stuff. I'm going to plug in f of x. X will stay the same. So my h value, let me see if I can keep the same colors I used from before. We're going to go left 2. That's going to be my h. And once again, it's backwards. So if I'm going left, I'm actually going to add that number. And then my k value is what determined that we'll go up 4 places. So we're going to add 4. like I mentioned, there is definitely going to be an a value in this one that is not equal to 1. So we're going to need to do something else. So if I go back here, what I did is I took that second point. All right, in this problem, it was 4, 4. This time they gave me the point. It was very kind of them. 0, negative 12. So I'm going to use that 0, negative 12, and I'm going to plug in those values. So let's rewrite this with the y value so it's a little more clear what we're plugging in. So y is going to be negative 12 is equal to a times x, which in this case is 0, squared plus 4. And now that we have just a is the only unknown, we can solve this for a. So 0 plus 2 would be 2 squared plus 4. So I'm going to get negative 12, 2 squared would be 4, so I have 4a plus 4. Subtract 4, then divide by 4. So a is equal to negative 4. Now, how do we know that's correct? Well, one, we can plug in other points into the eventual equation we get. But one of the key things I would definitely note here is this negative. Right. My parabola is kind of upside down. It's reflected. So that a tells me that should have been reflected. All right, it should be upside down, which at least I know I have the negative, right? So I'm going to take these numbers and plug them in as my final answer. So f of x is equal to my negative 4, x plus 2, that represents the shift left, squared, plus 4 represents the shift right. So this a value went here. Remember, this was our h, and this was our k value. If I really, again, wanted to check this, I can pick some other points. It looks like we have the point negative 1, 0 here. You could plug that point in and see if your equation balances, but we're going to leave this as is, and we're going to stop there.